Hello friends, today in this video I am going to talk about prochirality. So what is prochirality? Prochirality refers to a property of an achiral molecule. Your focusing point here, achiral molecule, that can be converted into a chiral molecule. Keep in your mind achiral to chiral molecule by a single substitution or transformations. Here also a boundary, a single substitution or transformation. Prochiral centers and phases play a crucial role in stereochemistry, particularly in enzymatic reactions, asymmetric synthesis, and drug design. My friend, prochirality have different types. So type 1, prochiral center or prochiral atoms. A tetrahedral carbon or other element bearing two identical substituents can become chiral if one of those substituents is replaced by a different group. For example, in ethanol CH3CH2OH, the carbon bearing the hydroxyl group is prochiral because replacing one hydrogen with a different group creates a chiral center. Now, prochiral phases. First I talk about the center, now phases. Phases related to the planes, prochiral planes. So a trigonal planar sp2 hybridized carbon in a molecule with three different groups attached can have two distinct phases. One phase called Re and the second one is SEI. So Re and Si depending on the priority of the substituents. Now, for example, the carbonyl carbon in ketone, CO, For example, acetophenone has two distinct phases which are important in enantioselective reactions like reduction. Now, designation of prochirality. Pro-R and Pro-S, nomenclature for tetrahedral center. My friend, if replacing one of the two identical groups with a higher priority group results in an R configuration, the original group is called Pro-R. If it is result in S configuration, the original group is called Pro-S. Now, Re and Si phases, proplanar center or for planar centers. So, Re and Si phases, how you will understand Re and C phases in a planar molecule. Example, carbonyl or alkanes. If the priority sequence follows a clockwise direction, the phase is called Re. If it is follows a counterclockwise direction, the phase is called Si. Now, I am going to give you examples of prochirality. So, take one example of prochiral carbon center like ethanol. In ethanol, the CH2 group is prochiral. Keep in your mind, CH2 group in ethanol is prochiral. Now, Glycerol, you know OH, CH2, CHOH, CH2H is the formula of glycerol. The central carbon is prochiral, making glycerol important in biochemical reactions. So, prochiral phases in carbonyl compounds. Acetophenone, the carbonyl carbon has two distinct Re and Si phases, as I already told you, affecting the stereoselectivity of reductions. Alpha-beta unsaturated ketones, enzymatic additions often occur selectively at either Re or Si phases. My friend, the importance of prochirality in chemistry. Enzyme catalysis. Many enzymes recognize prochiral molecule and catalyze stereoselective reactions. For example, alcohol dehydrogenase reduces ketones to enantiomerically enrich alcohols by selectively approaching the Re or Si phases. The second one, asymmetric synthesis. You know, the asymmetric synthesis is also very important roles in chemistry. Prochiral centers are key target in asymmetric catalysis to obtain enantiomerically pure products. For example, hydrogenation of prochiral alkenes using chiral catalysts like Wilkinson's catalyst. Now, the drug design and pharmacology. So, many drugs contains prochiral centers and that influence their activity and metabolism. For example, ibuprofen is marketed as a racemic mixture, but only the S enantiomer is pharmacologically active. So, in conclusion, prochirality is a fundamental concept in stereochemistry with widespread implication in organic synthesis, enzymatic reactions, and drug development. Understanding prochiral centers and phases helps in designing selective and stereospecific transformations in chemical and biological systems.